Good morning everyone. Now today we will discuss on topic force and pressure. Contact and non-contact forces. A force is seen to act through a direct contact of the objects or via one more object. Such force is called contact force. Example, muscular force. A force is applied between two objects. Even if the two objects are not in contact, such a force is called a non-contact force. Example, magnetic force, gravitational force and electrostatic force. Examples, a coconut is falling from the coconut tree. Objects are attracted to the earth due to the force of gravity. When a comb gets rubbed against hair, small pieces of paper kept on a table get attracted to the comb. Comb, electrostatic charge and pieces of paper and induce opposite charge. Next point, balance and unbalanced force. If the force is more on one side, the rope moves in that direction. This means that initially the two forces are balanced. The rope moves in the direction of higher force when the forces become unbalanced. Now we can see next point, inertia. An object changes its state of motion due to force. In the absence of a force, objects exhibit a tendency to remain in the existing state of motion. Then we can see the tendency of an object to remain in its existing state is called its inertia. Types of inertia. Inertia of the state of the rest. Second, inertia of motion. And third, directional inertia. There are three types of inertia. Pressure. What is meant by pressure? Now we can see definition of pressure. The force exerted perpendicular on a unit area is called pressure. What is the formula of pressure? Pressure is equal to force upon area on which the force is applied. Then we see unit of pressure. The SI unit of force is Newton, means N, capital N. The SI unit of pressure is Newton per meter square. It is known as Pascal. 1 bar is equal to 10 raised to 5 Pa. Pressure is a scalar quantity. Camel's feet do not penetrate into the sand and it becomes easy to walk. Next point, pressure on solids. Air pressure is exerted on all the objects kept in air. When a weight is kept on a solid, pressure is exerted on it. Now we can see pressure of liquid. The pressure increases as the depth of the liquid increases. Gas pressure, a fluid enclosed in a container exerts its pressure equally in all directions at a point within the fluid. Next point, atmospheric pressure. Air surrounded the earth from all sides. This layer of air is called atmosphere. The atmosphere exists to about 16 km height. It further extends up to about 400 km in a very dilute form. The pressure created due to the air. The air pressure at the sea level is called 1 atmosphere pressure. Air pressure decreases as one goes up in height from the sea level. 1 atmosphere is equal to 101 into 10 raised to 3 Pascal is equal to 1 bar is equal to 10 raised to 3 m bar. 1 m bar is equal to 10 raised to 2 Pascal, means hectopascal. Atmospheric pressure is specified in the units m bar or hectopascal, means HPA. Next force we can see buoyant force. The upward force acting on the object in water or other fluid or gas is called buoyant force, means FB. It becomes easier to swim in sea water than in fresh water. This is because the density of sea water. higher than the density of fresh water due to salts dissolve in seawater. Volume of the object, the buoyant force is more if the volume of the dipping object is more. Density of liquid, more the density of liquid, more is the force of buoyancy. Next, Archimedes principle. What is the statement? When an object is partially or fully immersed in the fluid, a force of buoyancy acts on it in a upward direction. This force is equal to the weight of the fluid displaced by the object. The use of Archimedes principle very wide. This principle has been used in the construction of ships and submarine. Hygrometer are based on this principle. Density of substance and relative density. What is the formula of density? Density is equal to mass upon volume. SI unit of density is kilogram per meter cube and relative density is equal to density of substance and density of water. Now we can see some examples. First example, the area of the bottom of a tiffin box is 0.25 meter square and weight is 50 Newton. Calculate the pressure exerted by the box on the shelf. Now we can see solution. Given, which are given, area is equal to 0.25 meter square, weight of the box is equal to 50 Newton and we search pressure. What is the formula of pressure? Pressure is equal to force upon area. Force is equal to 50 Newton upon area is equal to 0.25 meter square. When we divide 0.25 to 50, then what is the answer? 200 Newton per meter square. Okay. Then second, calculate the relative density of iron. If the density of water is 10 raised to 3 kilogram per meter cube and the density of the iron is 7.85 into 10 raised to 3 kilogram per meter cube. Which are the given? Density of water is equal to 10 raised to 3 kilogram per m cube. Density of iron is equal to 7.85 into 10 raised to 3 kilogram per meter cube. So, we need relative density of iron. What is the formula of relative density of iron? Is equal to density of iron upon density of water. They are given 7.85 into 10 raised to 3 kilogram per m cube upon 10 raised to 3 kilogram per meter cube. What is the answer? 7.85. Here are not given any unit because kilogram, m cube. Okay. So, next 3. The area of the tip of a screw is 0.5 mm square and its weight in 0.5 Newton. Calculate the pressure in Pascal exerted by the screw on a wooden plug. Now we can see answer given, which are given in this example, 0.5 into 10 raised to minus 6 m square. Then weight of the screw is equal to 0.5 and we need pressure. Pressure is equal to weight upon area. What is the weight? 0.5 and area 0.5 into 10 raised to 6 m square. So what is the answer? 10 raised to 6 Newton per meter square means 10 raised to 6 Pascal. We are converted this unit n per m square into Pascal. Okay. Understood? Thank you.